Click yes to see the result. It will generate crystal report for you. Okay, this is what we're familiar with. Click the plus sign at the unnamed project. If you remember, usually we see the report for entity, queue, and resource. Now we see another one, user specified. This is when we ask Arena to calculate any additional statistic. That is not the default. Okay? So click on user specified. Okay? And take a look at it. User specified. We have two types that we create, time persistent and output. For time persistent, we have number in queue. Remember, it should be the same, exactly the same name as what you specify. In the report, it will just show you the average number in queue, minimum and maximum. Okay, the report will just show this. It will not show all the number in queue that happened. For the output, we want average number in queue. So it's only one number for each replication, which is 1.57, which is basically the same as the number in queue here. Because this one, it collects the number in queue data, but it will calculate the average information. Okay? That makes sense? Alright, if it's okay with you, what I would like you to do is to close the report. Okay, close the report, end the simulation run, and I would like you guys to generate another type of a report, assignment summary report. Okay, so to remember, go to run, setup, okay, run setup, find the tab name report. Right now the default report is category overview. We will change to assignment summary report. This is for when you did the exercise number 4, right? Ask you to calculate, to generate assignment summary report. Click OK. Rerun the model. Okay, and then you click yes again. This time you'll get the assignment summary report, right? So let's take a look together again, okay, to see the information here. Okay, it will give you this information. This is summary for replication 1 of 1. Base time unit is minute. We run for 960 minutes. And you can see here that in this type of report, they try to separate different type of the statistic. So the first one is tally. Remember the tally? Okay. For the tally, you will see that any information regarding the time for the entity or the waiting time is considered tally variable. So the easiest way to do or to read, you can see that, okay, at the end of each identifier, you have like VA time, non-VA time, wait time, transfer time, other times, and total time. And in the front is the entity. So if you have different type of entity, it will calculate the time for different type of entity. That's exercise number 4 that you did. Okay? And tally variable also include waiting time in the queue. So we have only one queue, check-in.queue and the waiting time. Okay? The second one that we see is discrete change variable or time persistent variable. That's the same thing. Discrete change or time persistent variable. And now you can see that number in queue that you ask the statistic model to generate. Now is appear here, number in queue. and show the average, minimum, and maximum. Also the final value. This one we didn't see in the crystal report. Okay? And then anything that related to number BC, utilization, okay, number BC, or number in queue, it will be under discrete shape variable or time persistent. So you can see that check-in.queue.number in queue, it will have the same information as the number in queue that we asked them to collect separately. Okay, average is the same, minimum, maximum, final value. Okay, and the last one is output. Right, you can see that for each simulation run, you have only one output number. It will return the last value. For example, we collect average number in queue. Now it's appear here and just give us the average value, which basically you can get this average value at the end of the simulation run, right? That you collect all the statistics. And then number in queue, number out, okay, is also considered output variable. Okay, that makes sense? So now you can see that when we use the statistic model, okay, to generate the data, okay, it will also show in the report. That makes sense for everybody? And if you want to take a look at the data files that Arena generate, you can go to the folder that you asked it to generate the data. Okay, it may mix up with many information, don't worry, but for mine, okay, you see average number in queue.dat and number in queue.dat. Okay, so what we're going to do is, now we're going to use output analyzer to analyze the data from these data files. Okay, .dat files is a format that output analyzer can read. Okay, so save the model, and now open output analyzer. You're going to have to open it as a separate program. So output analyzer. Now we are moving to part 2 in lab 5. Okay, now we are moving to output analyzer program. Everybody okay starting the output analyzer? Okay, seems like nothing in here. So before we start doing the confidence interval or companion, I'm just going to show you one function that output analyzer can do is to create the plot. Remember current number in queue? If you want the plot of the current number in queue, you can use the plot in Arena, or you can generate the graph here too. So go to graph, and then plot. Okay, this is the usual format of the output analyzer. That every time you want to do something, you will have to add the data files. So add the data files so that it will use it to do the analysis for you. Okay, so here you click on add. Okay, it will ask you to browse for the data files. So click browse, and then go to the folder that you save the files. This one we're going to choose number in queue because it's the one that we can plot the graph. Okay, so choose number in queue.dat. Open. Replication, you leave it at 1, that's fine, okay. Here, if you want to specify the label or the title, that's fine. I'm not going to do that. It's because I'm lazy. So then we click OK. Okay. Once you click OK, now you're going to see the graph, which is exactly the same as the plot that you have when you run the simulation. Okay, because it collects the same information, current number in queue. and the y is the number in cube, x is the time, okay? And we run for 8 hours, okay, so 960 minutes. That makes sense for everybody? So you can generate the graph here, or just run the model and get the graph here, okay? Or if you don't want the graph, but you want to see the raw data, okay, of the current number in queue, you can go to graph and select table, and again add the same data files, okay, graph and then table, select the same data files, number in queue, and then click OK. OK again, and OK to get out. Okay, so you get the raw data here. So you can see that the first column is the x-axis or the time, and number in queue is here. So basically, it will collect the information when number in queue change. Right? At time 0, number in queue is 0, but at time 23.2, it become 1. And then 24.2, it go back to 0. Okay, so you can take a look at the information. Okay, it will collect any change that happened until the end of the run. We still have the final value of 3. Okay, so 3 number in queue. That makes sense for everybody? Okay, you can generate this, right? So this is just for your information, because some of you, sometimes you may want to get just the raw data, and then you use Excel or others program to plot the graph. Okay? All right? So if you're okay with the graph here, now what we're gonna do is we're gonna use output analyzer to calculate the confidence interval for us. Okay? Actually, for the confidence interval, it's basically the average number plus or minus the half bit, right? But we can also ask the output analyzer to calculate for us. But whenever we're talking about confidence interval, it means that we're gonna have to run more than one replication, right? If you run only one replication, as a result that you see earlier, it will try to calculate half bit, okay? But most of them, it will say insufficient or correlated, which means that it cannot calculate. Okay? So what we're gonna do is, please go back to your model. Okay? And we're gonna try running the model for 30 replication. Okay? When you see number of replication more than one, definitely we're focusing on the output statistic. Okay? You guys still remember how to change the number of replication? We go to run. Setup, replication parameter tab, you change from 1 to 30. Okay? Before you click run, remember, if you do the animation, it will take some time, right? When you want to generate many replication, we don't care about animation anymore. So we're gonna turn off animation, go to run control, and then batch run, no animation. Okay, run control, batch run, no animation. And now you can just click run or go. It will go very fast. Once you're done, click yes to see the result. Just want to show you a little bit more before we go into output analyzer. Alright, everybody get the result? So you have the result on your screen, right? Again, the first one, it will be exactly the same as what we see before. But now you can see that it says summary for replication 1 of 30s, because we added to run 30 replication. If you scroll down, you'll see summary for replication 2 of 30, 3 of 30s, and so on. Okay? And then if you scroll down to the end, you will have output summary for 30 replication. Okay, this is a summary for all 30 replication. that we did. And you can see that average number in Q, right? You basically is collect the average number in Q for all 30 replication and calculate the average. So you get 2.6241. And of the 30 replication, now you can calculate the half bit, 0.56719. So if you want to calculate the confidence interval, you can just do 2.6241 plus or minus 0.56719. You can do that too. Or you can ask Output Analyzer to generate it for you. Okay. The interesting thing that you should check every time is to check the number of replication. It's 30 because we ask them to run for 30 replication. Okay. Okay. Now go back to Output Analyzer. Okay, and then go to Analyze. Okay, Analyze confidence interval on mean. Okay, Analyze confidence interval on mean, classical. Okay, and then click, just click on that. Sorry, you will get the new window. Again, it will ask for the data files that you want it to calculate confidence interval for you. So click Add, and then browse for the data files. This time, we're gonna select average number in Q. Okay, so each replication will have only one average number in Q. Click Open. This one is very important. Replication, click on the drop down. We're gonna choose lump. Okay, if you choose one, it means that you have only one replication, which is wrong. Okay, so you're gonna choose lump. When you choose lump, okay, it means that Output Analyzer will use all 30's information from 30 replication together. But if you select all, it will treat that 30 number as one replication, so it's wrong. Okay, so just make sure. A lot of people make mistake here. So replication, you choose lump in here. Okay, and then click OK. You will see that for the confidence level, the default is 95%, but you can choose 90 or 99% too. Okay, we'll keep it at 95. And then click OK. Once you click OK, now you see the confidence interval for average number in Q. Okay, the text down here is pretty much the same as the text file that of your output, right? Telling you the average number. It also can calculate standard deviation and 95% half it. Okay, so it's right here. Or you can take a look at the picture here. So the middle line here, the red one, is the average number. And the blue bar here represent the confidence interval. Okay, 95% confidence interval. So the minimum number is 2.06 to 3.19. So we are 90% sure that average number in Q will fall within this interval. Okay, this 2.06 and 3.19 is coming from 2.62 plus or minus 0.567. Okay? And the minimum maximum value here is like the actual minimum and maximum value that you find in the 30 application. Okay? When we do the conclusion, we can only say that we are 95% confident that the average number in Q will fall between 2.06 to 3.19. Right? That makes sense for everybody? Do you guys have any question on generating the data files and also on calculating the confidence interval? Yes. Sorry? You cannot get this? Okay. Let me take a look. But for those of you who are okay with this, we're going to move to part number 3. And what I would like you to do first is to open your hands-on model. Okay? For those of you who did it wrong or couldn't get the result as stated in exercise number 4, you can also download the hair salon model from Week 8 result analysis. Okay? But if you do it correctly, you can just use your own model.
ที่ต้องเปลี่ยนเบส3ให้เป็นมินิอยู่ในที่เราดูในร้านเซตอัพนะครับผมก็เคยเข้าขายกันเลยเพราะว่าผมแค่ล็อกเครื่องตัวเองก็ไม่ได้เนี่ย
Okay, everybody else okay with that? Okay, any question about part 2 for confident interval? So everybody okay with this, right? Okay, now we're gonna move to part 3. Okay. Because now we learned how to do the graph, the plot, and also confident interval. Now we're gonna move on to part 3. Okay. We basically gonna do the same thing first. Okay. Configure your model, Hasselblad model, from exercise number 4, so that it can generate output files. And then we will do confident interval. Okay. So you can save model 5 and then close it. And then open Hasselblad model. Okay, I'll wait a little bit to make sure everybody get the model. Once you open the model, just run once to check on the number. I think it should be okay. It's 17. So if you get the same number out, that should be okay. Okay, if you don't have the model or your model is wrong, okay, you can download the model from Week 8 result analysis. I have Hasselblad model down here. Okay. Okay, I'll give you a couple minutes to get the file ready. Okay, get the files, run the model, make sure that the results are correct, and then we will continue from this. If you have any question, any problem, then raise your hand. help you.